All right, class, this is just some notes from page 420. We'll try seeing how this works to get information out to you. Anyways, on page, so here's what we're doing in this section. We're going to try and compare two samples, trying to see if one has a greater mean than the other. If you look on page 419, you can pause it right here. They bring up an issue between male college students and female college students. It says the mean of the male college students is 85 minutes. The mean of the female college students is 81 minutes. Didn't actually, the amount of time they spend online. So the question could be, is this a significant difference, 85 to 81? Or are these really just equal, just based on the sample size? And if we really got more students involved on each side, would the law of averages come out and they would just end up evening out, or the difference being not significant? So that's what this is about. This section is about, is testing two different samples and seeing if there's a significant difference between their means. Okay, so then turning to page 420 here. So it describes in the box on the top, it has the null hypothesis. The null is still going to have these three symbols, okay, less than or equal to, greater than or equal to, or just the equal sign. The alternative will not have the equal symbol. It's still going to be just less than, greater than, or not equal to. Okay, so below that describes the three different tests that you'll be doing. HO, HA, they're both equal to. HO and HA, where HO is less than or equal to. I hope you can follow along. I don't have a book here that I'm kind of showing you. You should be following along, page 420. Okay, next page, page 421. You can use a two-sample z-test when the following conditions are met. You can use a two-sample z-test to compare the differences between two population means when the following conditions are met. And many of these conditions are going to look familiar. Both population standard deviations are known. Whenever we do a z-test, we need to know the population standard deviation. So that doesn't change from the previous chapter. The samples are random. The samples are independent. We just talked about that in the previous video, example 1. Obviously, with the problem I just described on page 419, you have male students and you have female students. There are no individuals in the male group that are also in the female group. They are separate. They're independent. And then the last one we've seen before, populations are normally distributed, or both sample sizes are greater than or equal to 30. Okay, so what you probably really want is, well, how do we do the problems? Because you guys just want to know how to do the problems. So I'm going to show you how to do the problems using the calculator. All right, so the next page here, this is example 2. So in example 2, they want to compare the difference in mean credit card debts of households from California to Illinois. Now they give all the information in the problem, but and I'll show you how to put that in the calculator. But the first thing I want to find are the critical values, okay? Because on the online, they like to get these critical values, even though we know that all we really need is the p-value to compare it to our alpha value. But let's go ahead and find the critical value. To find the critical value, we're going to use inverse norm, because this is a z-test. So inverse norm, go down here. This is a two-tailed test for this problem, because we want to know if they're equal to each other, or if there is a difference. So we want to know if they're equal to each other. So what we're going to do is take 1 minus our alpha value of 0.05, because remember, this gives us the center of the curve. So we've got, right? So our alpha value, we want to find out this area here and this area here when we're two-tailed. So We're going to use that feature on our calculator, but what we need to do is take 1 minus our alpha value, because this area and this area are what we want to be the 0.05. But when we use this inverse norm, it has it in this area. So we don't want this to be 0.05. So we want to take 1 minus 0.05 to be this area. That's why we used what we did on our calculator. All right, so let's see if I can get back here. Okay, there it is. All right, so we want to go to center, and we're going to hit paste. So these are our two critical values, negative 1.96 and 1.996. So I go back to here. These values are negative 1.96 and positive 1.96. So that's our critical values. All right. Now we can do find our test statistic and our p-value, and we can determine whether or not we're going to reject or fail to reject. So the test we want to use is a 2-sample z-test, because we know the standard deviations. Obviously, I hope you know where we're going with this. The next section, we're not going to know, not the standard sample. We're going to use z-test because we know the population standard deviation. But hopefully you can see where we're going. We're going to use this one for the next section because we will not know the population standard deviations. Okay, so this looks like a lot of data to put in, but it's all right there in your book. So it gives you this number in the problem, 1045. Then it's 1350 for California, and it even tells you this is number 1, this is number 2. And then it goes over, then you use the little box to the left. California has 4,777 as their mean of debt per household. Illinois has 4,866. This sample was 250. What am I doing here? Hold on. Sorry about that. This sample is 250. I was 1 line off. I'll put these in and I'll explain what I'm talking about here. Okay, so this 4,777 represents the mean for California. N1, so the sample size for California was 250. X bar 2, the mean for Illinois is 4,866. Sample size 2, 259. This is our alternative is not equal to, so we keep that. There we go. So we have a z-score of negative 0.833, a p-value of 0.405. We put that into our little chart here. So test statistic, negative 0.833, and a p-value of 0.405. That's correct, right? Yes. Okay, so what is our conclusion? Our HO states that they are equal, and that's our claim. With a p-value this high, okay, and our alpha value at 0.05, right? Our p-value is less than or equal to, is not less than or equal to. If it was less than or equal to, we would reject. It's not less than or equal to, so we're going to fail to reject. And since the claim is with the AO or the HO, looking back on page 356, if the claim is with HO and we fail to reject, there's not enough evidence to reject the claim that there is a difference between the debt, the credit card debt for households from California to Illinois.